Hey guys, welcome back to my channel. This is Offender, and today we're going to deep dive into HSRP, which is Hot Standby Redundancy Protocol, and IPsec over GRE, right? IP Internet Protocol Security over Generic Routing Encapsulation. So, without further ado, let's start. Again, this is a lab I've created on my own, inspiration with others, but specifically with Jeremy's IT Labs and his course. But this was my own take on being able to configure IPsec. I actually learned IPsec on my own, but through his course I did learn and understand how to configure GRE, right? So that we're able to establish a tunnel connection between, you would say, two networks, as if those two networks are within the same LAN, right? So yeah. So over here, I have a note that says IP addresses, host names, and OSPF are pre-configured, right? So we don't have to configure IP addresses, host names, or OSPF. But if you do want to understand how that works and how to configure that, check out my previous labs on OSPF and VLANs, right? So right here, I have two layer 3 switches. Both of these switches have links to the internet, right? And the internet is going to be Google's DNS server, which is 8.8.8.8. So the first task is we're going to configure HSRP on switch 1 and switch 2. When I say switch 1 and switch 2, I meant the layer 3 switches, not the layer 2 switches, right? And we're going to use a virtual IP address for redundancy, and that virtual IP address is going to be 10.0.0.254 because we're on this /24 network, right? Leaving us with a total of 255 IP addresses. Remember, we got to reserve 0 and 255 for the network and broadcast address, leaving us with the last usable address of 254. And so we have user Mike Tyson here. Mike Tyson is going to want to connect to the internet. And doing so, let's say there's a few connections here that we lost, right? Let's say switch 1, layer 2, switch 1, and layer 3, switch 2. Let's say they're offline, and Mike Tyson no longer can connect to the internet because they had a default gateway of 10.0.0.2, which is layer 3 switch 2's IP address, right? So we want to avoid that and configure HSRP, where Mike Tyson has a virtual IP address of 10.0.0.254, where it doesn't matter which physical device, network device, it's going to establish a connection with the internet, right? So then task 2 is we're going to verify that Mike Tyson is able to access the internet even if multiple links are down, which I just explained just earlier. And task 3 is we're going to configure an encrypted link via GRE tunnel from user admin to server 1. So we have two networks here. We have Office using IP address of 192.168.1.0/30, where our admin is located with a .2 address, right? And then we have our server here, which is 192.168.100.2, which is on this sub network right here, right? They're both on using /30. So it's enough for two IP addresses, right? One for our WAN's interface and one for the end host device. So what we're going to do is we're going to say, hey, we want admin to establish a connection to server 1. But the only thing is that we want to encapsulate those packets and encrypt them, right? So being able to establish a tunnel connection, we're going to use a subnetwork right here, which is 172.16.0.0/30, right? So R2 is going to have a tunnel interface of .2. R1 is going to have a tunnel interface of .1. And so admin is going to essentially go, the first hop is going to be our G01 interface on R2, which is 192.168.1.1. And then from there, the next hop is going to be R1's tunnel interface, which it'll be 172.16.0.1, and then from there it'll go to server 1, which is our destination. But then we're not going to be done there because we're going to want to encrypt those packets, right? Because by default GRE does not encrypt those packets. Instead, it establishes a tunnel connection where it's able to, you would say, encapsulate most network traffic to its destination, right? Again, it doesn't perform encryption by default. That's where IPsec is going to come in, and another protocol, which is ISAKMP, which stands for Internet Security Association and Key Management Protocol, where both of these devices are going to establish, you would say, I wouldn't say a handshake, but I would definitely say establish some sort of understanding or deal, saying, hey, okay, we both agree to these configurations on how to establish a security association, right, through IPsec. Once that has been established, that's when IPsec is going to come in and encrypt those packets, right? And then for task 4, we're going to verify if user admin is able to access a server via encrypted tunnel. Server cannot access internet, but the admin should be able to access the internet without the tunnel, right? Again, we're going to verify if admin and server are able to have encrypted packets during the transmission, and then have admin ping the internet without having to go through the tunnel, right? So again, I hope you guys understand what this lab entails. So let's get straight to it, right? So we're going to start with switch 1 layer 3. We're going to start configuring our HSRP. So we're going to command line interface, enable config T. Again, everything is pre-configured. If you want to see here, our physical interfaces G001 and G102, right? Along with the static route to the internet, right? And then we have OSPF here configured with the network of 10.0.0.0/24 on area 10. And then the static route has been distributed across all other, you would say, OSPF neighbors, right? So without further ado, let's go. Let's get to it. So we're going to do interface G103. The reason why I picked G103 is because this port has an IP address, and it's going to serve as a default gateway for Mike Tyson, right? So I'm going to give you a quick example before I even configure HSRP. So for example, this is the default gateway, right? 10.0.0.1, which is switch 1 of our layer 3. So I'm going to go to desktop, command prompt, and let's trace route the internet, right? Our ping to the internet. So it goes to 10.0.0.1, and then the internet, right? So let's double check our ARP table, which is our address resolution protocol. Be able to translate between IPs and MAC address and IPs, right? So this is the physical address of our switch for switch 1. Now let's say I want to change the default gateway to that 2, right? Okay. Can we still ping the internet? So the next hop is going to be our layer 3 switch 2. So it was a successful ping. So now to see our ARP table, you see a different physical address, right? Which is a different MAC address of this switch, right? Physical, definitely different devices. What we're going to want to do with this case is we're going to say, hey, we're going to have a virtual, not just a virtual IP, but also a virtual MAC address that HSRP used, right? So I'll show you guys once we configure HSRP on both of these switches. So we'll do standby. Now we're going to set a group number to 1. You can set any group number, but I'll just start with 1. And then I'm going to specify the IP, right? So the virtual IP is going to be 10.0.0.254. Standby 1. Now I'm going to set a priority, right? Basically what a priority is saying, hey, the network device that has HSRP configured with the highest priority is going to take the place of saying, hey, I'm the default gateway, right? In other words, it's going to be the active gateway or router. So I'm going to set a priority of 110. standby 1. Now I'm gonna issue the preempt command, which says, hey, let me give you an example. So let's say I'm going to configure a priority of 115 on the switch 2. So for example, Mike Tyson's going to, the default gateway is going to be virtual IP of .254, but it's going to go to the switch 2, right? That packet is going to, the next hop is going to be switch 2. Hypothetically speaking, let's say switch 2 is offline, or, there's a DDoS attack being a scenario some sort, and let's say switch 2 is down, right? So then with the preempt command, switch 1 is going to say, okay, hey, this switch 2 is down, so I'm going to be the next active router. And that's basically what that command is going to do. It's going to overthrow lower priority active routers. Okay, I'm going to do right, save this in my configuration file. Now we're going to do the same thing on our layer 3 switch 2. Enable config T, interface G105, standby 1 IP .254, standby 1 priority. Remember the priority was 110 for switch 1. I'm going to set the priority for 115. And then preempt, right? Okay, do right. Alright, so now we're good. Now let's go back to Mike Tyson. Let's change default gateway to 254. Now, let's ping the internet again. Okay. So it goes to .2, right? It'll go to our layer 2 switch right here, right? Now, if I were to issue the ARP command, show our ARP table, you see here that the default gateway is .254, and the MAC address is not neither of them, right? So it has its own virtual MAC address, which is HSRP versions of the MAC address, right? So what happens if I let's say this becomes offline? Let's unplug it. So now switch 2 is definitely offline. Let's go back to Mike Tyson. We don't have to configure default gateway. It's going to stay to the virtual IP address. Let's see, can we still ping the internet? And we still can. But the next hop was .1, which is switch 1, right? So let's see the ARP again. Okay, it's the same thing. But what if I want, let's clear our ARP table. Okay, there's no ARP entries found. So let's do another ping. And again, the IP is .254 with the same virtual MAC address that switch 2 had because of HSRP. So that's it for part 1 of this lab. We configure HSRP on switch 1 and switch 2 to use a virtual IP address for redundancy. If there were any failed links, we verified that Mike Tyson is still able to access the internet even if multiple links are down, right? So now let's configure an encrypted link via GRE tunnel from user admin to server 1. So let's start with R1. Enable config T. Do show run. Let's see any previous configurations that we have here. We only have host names and physical interfaces, but there's no static route, as you can see here, and there's no OSPF configured whatsoever, or any other types of routing protocol. So if to configure GRE, right, GRE stands for generic routing encapsulation, being able to configure a tunnel, right? So if you want to configure a tunnel, interface question mark. Remember how in the previous slide we were able to configure a loopback address. Now there's a tunnel right here, configure a tunnel. Now there's an additional command here which is tunnel, but first let's specify the IP address of our tunnel, right? So the IP address is going to be 172.16.0.1, which is right here, right, closest to R1, with the /30. So it'll be 252. Okay, well, now we go to tunnel, and now we have 3 available commands here. We're going to specify the source. The source of our tunnel is going to be our G00, right? That's how admin is going to be able to basically ping server 1, right? It'll go from the packet will go from switch 8 to router R2 to switch 6 R1, switch 7, and server 1, right? So this is going to be the source because it's closest to admin. So we'll specify G00 tunnel. Now the destination, it's not going to be the network address of 192.168.1.0/30, nor is it going to be 192.168.1.2 admin's IP address. Instead, it's going to be the next hop. The next hop, which is going to be R2's G00 interface 10.0.0.4. Now the interface is up. Okay. We're not done here yet. We have to establish a static route. So we'll do exit IP route, because the tunnel doesn't know where that packet is going to land, right? So we'll do IP route 192.168.1.0 255.255.255.252. Next hop is going to be 172.16.0.2. Now, basically, we're saying is, hey, let's route our destination. The destination that we want to go to is 192.168.1.0/30, but the next hop is going to be the next available IP address within this tunnel subnetwork, right? So now we'll do the same thing on R2. Config T interface tunnel IP address 172.168.0.2 255.255.255.252. Okay, tunnel source is going to be again G00, and then the tunnel destination is going to be the IP address of R1's G00 interface. Okay, again, we're not done. We have to specify a static route. 2.168.100.0 255.255.255.252 172.16.0.1. Okay. So that's it for configuring GRE. Again, nothing so far is going to be encrypted, but we are able to ping server 1, right? Again, if you want to see here, there's no OSPF for any routing protocol enable. Do show run. So we establish a static route with our tunnel interface. So we go to command prompt and let's say trace route 192.168.100.2. Okay, so you see that the next hop was R2, and then the next hop after R2 was R1's tunnel interface, and then from there we ping server 1. So basically we went from admin to R2 to our tunnel interface to R1, and then our server, right? Now nothing is encrypted. So we just configured a tunnel, right? So what we're gonna do is, okay, now we want to encrypt those packets or encrypt that traffic, right? So for example, let's say admin wants to establish a telnet connection to server 1, right? Knowingly, the admin understands that, let's say telnet is, because telnet is not encrypted by default. A better choice is SSH, but let's assume there's another worker that uses admin's PC or whatnot and doesn't know that telnet by default uses no encryption. So unknowingly, that user, which is another admin, right? Let's say a newbie, or establish a telnet connection with server 1, right? Now, there's an attacker sniffing connection, or let's say a rogue device or a disgruntled employee, right? Let's say they're sniffing the traffic that's going between all routers, right? And they're using Wireshark, and so they happen to see a telnet connection, and they're able to sniff all the commands that's being used from admin to server, from configurations to creating users, changing passwords and stuff like that. It's very critical stuff. So in order to encrypt all packets, not just IP, right? It'll be all packets. It'll be routing protocols, remote connection protocols, so all sorts of stuff. We're going to use IPsec over GRE, right? Because by default, IPsec configures IP traffic only. GRE encapsulates almost all network traffic. So being able to combine best of both worlds, you're able to encrypt almost all network traffic with GRE over IPsec, or IPsec over GRE. So let's go back to R1 and let's configure IPsec. So we use crypto. Again, we only have one command available, but that's because we have, well, before I do that, let's write this to a configuration file, do right. Okay, so go back to R1, license, boot module, C2900 technology package, and that technology, there's two technology packages, but we're going to use security. So basically we're saying, hey, let's install this image of security K9, where we can do additional configurations with security. Okay, we're going to say yes. And now it wants us to save our configuration files and reboot. So we already saved the configuration file with do write. So we want to say do reload, confirm. Okay. Now it's rebooting. Let's do the same thing on R2. Security K9. Yes. Do reload. Okay, while that reloads or boots back up, let's go back to R1. Config T, crypto. Now we have additional commands that we're able to use, right? So we're going to start with ISAKMP, which is Internet Security Association Key Management Protocol. Okay, and we're going to specify a policy, right, for this suite. It could be from 1 to 1,000. Sorry, that's 10,000. So 1 to 10,000, right? So now our policy ID is 1, and we have another set of commands that we're able to use. So it's our authentication, and we're going to have a pre-shared key that we're going to specify later on with an encryption of advanced encryption standard, which is much more resilient than these other two options, with 256 bit. And then we're going to specify group. Commonly group 2 is used if Diffie-Hellman group 2, so we're going to use that for the sake of this lab. And then a hash, right? So the only available hash that we're able to use are MD5 and SHA. So SHA is much more stronger than MD5, so we're going to stick with SHA. And a lifetime. Basically, we're going to set the lifetime for our ISAKMP Security Association, which will be, we're going to use the last available secondary way to configure. Okay, we're going to do exit. Go back to crypto, ISAKMP. Now we're going to want to configure the pre-shared key for our remote peer. And the remote peer in this case is going to be 10.0.0.4, which is R2 G00 interface. So you can either specify an unencrypted clear text password. For example, it'll be password 1 for some people, but not for me. So what I like to do when configuring passwords for some things is I'll go to, let's say, a password generator, right? You can either write your own with Python, or you can search up password generator on Google and, be able to just generate a password. So we're going to start with a password length with 32 characters. And I'm going to copy this, right? So you would, you can have this as your pre-shared key password as well, but I'm not going to want to do that. I'm going to want to make this a little bit more complicated for a potential attacker or threat actor. So I'm going to go to my terminal. I'm basically going to convert this password to a hash value, right? And for those who don't know what a hash value is, a hash value, it's not the same as an encryption, right? Encryption, how encryption works is you have a text and converts as a gibberish, which is unreadable text. And basically, hash value is much more for integrity, right? Being able to make sure that nothing is tampered, a file or data has been tampered with. And encryption, again, is used for confidentiality. And how encryption works is basically you give it a file or content or types of data, and it'll output a randomized algorithmic set of strings, right? So echo, I have the copy password from last pass. I'll pipe that with SHA-256 sum, right? Now this right here is the hash value of this password. For example, let's say I were to delete 1, it'll be a different set of a hash, right? So you can see here, it ends with BA5 over here, and then the first one ends with FD1. So we're going to do the one with FD1. So I'm going to copy this. Now this is going to be my key, right? So it's going to be a hash of a randomized password with a high entropy value, right? So I'm going to paste the hash. Now I'm going to specify the address of our peer, which is .4. Okay, and then from there, now I'm going to go to IPsec, which is Internet Protocol Security, and we're going to set a transform set, right? The transform set, I'm going to call it IPsec. So IP capitalized and sec lowercase. Now you have a list of transform sets that you can or are able to configure. I'm going to specifically put the ones that I configured previously, which was AES with 256-bit and SHA with hardware MAC, right? And so ESP, yes, with 256-bit key, and then ESP with SHA hardware MAC. Okay, and then from there, I'm going to go to crypto and specify the map, right? This is what I'm going to use on our G00 interface and say, hey, I want these settings to be in place to establish, or you would say, encrypt all traffic coming from this interface. So anyways, I'm going to call this secure tunnel. The sequence, I'm going to put 1. IPsec, ISAKMP. Now we have another set of commands that we're able to use, right? So I'm going to start with set. Now I'm going to set the peer as R2's G00's IP address. Basically what the peer is we're going to be able to have G00 and R2, which is our destination, be able to encrypt and decrypt packets, right? So 10.0.4, sorry, peer, set peer. Okay, then we're going to set the transform set. Remember the transform set that we configured was IPsec, right? That's what I named it, capital IP and lowercase sec. And then from there, I'm going to match address, and we're also going to configure ACL to allow traffic with protocol GRE from host R1 to destination host R2. So I'm going to specify 100 because that's going to be the IP access list number I'm going to configure the ACL on. So we're not done yet. Let's configure our ACL. So access list 100 permit GRE host 10.0.0.3 to host, which is our peer, .4. Now we're going to go to that interface G00 and specify the ISAKMP map that we just configured. So crypto map, and now the map we named, which was secure tunnel. Okay, do right. Let's save our configuration file, and now we're going to do everything that we've done on R2, right? So crypto ISAKMP policy 1. Again, remember, authentication, encryption, group hash, and lifetime. So we'll start with authentication, which should be pre-shared key, encryption, AES 256, group 2, hash, which is going to be SHA, and lifetime, which is going to be 86400. Exit. Now we're going to go back to crypto ISAKMP key. Again, we're going to use the SHA-256 hash value, the randomized password that I received from LastPass. So we're going to paste that there. And address, which is our peer. This time it's going to be .3. Okay. Now from there, I go back to crypto IPsec transform. So this is where we're going to configure our transform set again. I'm going to name it the same thing, which is IPsec. And again, we're going to put ASP, AES 256-bit to SHA, the hardware MAC. Okay, crypto. Now we're going to specify our map, right? Yeah, map, crypto map, secure tunnel 1, IPsec to with ISAKMP, right? Again, I didn't really talk this on when I configure R1. Basically what this is, we're going to have IPsec work with ISAKMP. I'm definitely going to go over that towards the end of this lab after I show you guys how to configure this on R2, so you guys get a further understanding of how this stuff works. Okay, so it says this new crypto map will remain disabled until peer and invalid accesses have been configured, right? So let's set peer .3, and then we're going to set the transform set, which is IPsec, and then we're going to match address with IP access list number 100, which we're going to configure again just like we did on R1. Exit access list 100 permit GRE host .4 to our destination host, which is our peer .3. Now again, we're going to go to that interface G00, and we're going to want to stick that crypto MAC to that G00 interface, right? Where encryption and decryption is possible with destination peer, right? So crypto map secure tunnel. Okay, now If you want to see if the encryption is actually working, we're going to do show. We're gonna have an output. Do show crypto IPsec security association. Okay, so you see here you have basically what you've configured, right? So let's say we have ISAKMP. You also have when packets are, let's say, transmitted to the destination, we're going to see changes, right? We're going to see that we encrypted and decrypted packets. So let's have admin ping server1. Now again, the reason why it's taking a little bit of time is because these packets are going to contain a little bit much more overhead. You got to remember that it takes a little bit much more time because the encryption process is going on along with being able to encapsulate that packet, encrypt it, and then add an additional IP layer, right? So we see here that the ping worked. So we'll go back to R2. And you see here that we encrypted 10 packets and decrypted 9, right? So far we encrypted packets, which is pretty good. Can we encrypt more packets? And yes, we can. So we encrypted 16, right? So as you can see here, I showed you guys how to configure IPsec over GRE, right? Being able to establish a tunnel connection between admin and server 1. And also encrypt those packets, right, to prevent threat actors from sniffing your data, and also, configure a pre-shared key with a hash value that protects the integrity, and be able to, thwart hackers, make it harder for them to steal your data. So we're not done with the task just yet. So we did configure an encrypted link via GRE tunnel from admin to server 1. And then now task 4 is verify user admin is able to access the server via encrypted tunnel, which we did, and it works. Now make sure that server cannot access the internet, but admin should access internet without tunnel. Okay, so can we ping the internet? Nope, destination host is unreachable. Now server 1 ping the internet? Ping Google's DNS server. Nope. Okay, so that's good because again, we don't want server 1 to be able to access the internet. Server 1 clearly has some strictly confidential data, but we do want admin to be able to connect to the internet, right? So in order to do that, we go to R2. It says here that OSPFs are pre-configured and we have an OSPF area of number 10. So in order to do that, let's configure OSPF real quick. And you guys should know how to do that if you guys looked at my previous tab on OSPF. So we'll go to router, OSPF1. Again, now we're going to specify the address 10.0.0/24. So we're going to use wildcard area 10, and then we're going to specify our LAN network, right? .3 area 10. Okay, so we established an adjacency with 203.0.100.2 on our G00 interface, which essentially is this one right here, this switch one right here, right, layer 3. Do show IP OSPF neighbor. Okay, so now can we ping the internet? Yes, we can. So it works. We can definitely ping the internet, and we can also ping our server 1 through an encrypted tunnel, but we can also ping the internet through an unencrypted tunnel, right? So that's it for this lab. I showed you guys how to configure hot standby redundancy protocol between these two layer 3 switches, so that Mike Tyson is able to have still establish an internet connection regardless whether what link is down, right? and regardless of being able to have to configure Mike Tyson's default gateway multiple times, right? And so I also showed you guys how to configure an encrypted link via GRE from admin to server 1. Again, we created a GRE tunnel between the routers of 2 offices, right? Which is .1 and then .100. ISAKMP negotiates and establishes the security parameters between both of the routers, being router 1 and R2, and then from there, IPsec then encrypts and authenticates the data going through our GRE tunnel, which is on 172.16.0.0/30. Basically, any protocols that by default uses no encryption, now we don't have to worry about that because now they're going to be encrypted with IPsec, right? So, for example, you have Telnet and this, I believe it's FTP too. Yeah, FTP. Are unencrypted, and so being able to have that in place definitely creates a much more robust, strong network. Now, there are advantages to IPsec over GRE and also disadvantages, right? So I'm going to start with the advantages. The security, again, IPsec ensures confidentiality through encryption and authentication. And it's very versatile, right? You have GRE, which allows for encapsulation of various protocols, not just IP, and be able to encrypt those different types of protocol, not just IP, which is very helpful in any kind of network, right? Now, there are some things to consider, which makes this a slight disadvantage, especially in a large corporate network or even a large network. Definitely it's very resource intensive, right? So the combination of GRE, ISAKMP, and IPsec puts a lot of work on definitely say CPU resources, making it less suitable again for large networks because now you will have to invest in much more robust, stronger physical hardware equipment, right? And as the number grows with tunnels, again, there's much more overhead, which again affects the performance. But then again, if you really think about it, this is very ideal for a small to medium-sized network. If you want to implement something in a larger network, I would definitely recommend something like IPsec to VPN or even like other kinds of protocol that we'll talk later on throughout these labs. But yeah, thank you for tuning in. This is Defender. I hope you guys have learned something valuable.